Hello viewers, this is Josephine. Welcome to the channel. Today we are going to look at current electricity. If you look at this topic, current electricity, it's all about current and the thing that makes current to flow. So we're looking at current, potential difference, and also resistance. Okay, so first let's look at electric current. Electric current, the symbol is I, is defined as the rate of flow of charge along a conductor. The rate at which charge flows in a conductor is said to be what? Electric current. In other words, we can say that electric current I is quantity of charge divided by what? Time. Okay? That is I is equals to Q over T, right? When the unit of current is ampere denoted by capital A, we can also say that the unit of current is quantity of charge is measured in coulombs. This is coulombs over seconds. So it can say to be what? Coulombs per second. Okay? So quantity of charge is measured in coulombs. Then we can say to be coulombs per seconds. It's either it is measured in amperes or coulombs per seconds. Okay, all right, so let's look at the relationship between the current of flowing through a wire and the potential difference between the ends of the wire, and that relationship is what is said to be Ohm's law. So let's see what is Ohm's law. Ohm's law. Ohm's law says that the current flowing through a metallic conductor is directly proportional to the potential difference across its ends, provided that temperature and other physical conditions of the conductor are kept constant. Okay, so we can prove this law mathematically by saying that the PD across the ends of the wire is directly proportional to the current flowing through the wire. Now, in every law in physics, we must remove the proportionality sign to introduce a constant. Okay, so if we introduce a constant here, we're going to have V is equals to IR, where V is what? The potential difference, where V is potential difference measured in volts. I we already know as what? Current measured in amperes. Then the constant introduced is what is said to be what? Resistance measured in ohms. Alright, if you look at this resistance measured in ohms, then we have to know what is resistance and how we can arrange this resistance, because the three things work together. So a resistance is an opposition to the flow of electric current. Then we can say that we use a resistor to measure the amount of resistance flowing in the circuit. Alright, let's see how we can measure let's see how these resistors are arranged and how we can calculate the effective resistors when they are arranged both in series and in parallel. Let's look at resistors in series. Now, we have these three resistors arranged in series: R1, R2, R3. There are some things we must note. Look at this current, the current I that is flowing through these resistors. Because these resistors are in series, the same current flows. Okay? Remember that current always flows in series. Current always flows in series. So, because the resistors are also connected in series, so the same current that enters into the circuit is the same that flows here. For example, if I have the current of 2 amperes that enters into this circuit, we're going to have I1 to be 2 amperes, I2 to be 2 amperes, I3 to be what? 2 amperes. Okay, because they are all equal. All right, now this first resistance has a PD V1, second has a PD V2, and third has a PdV3. For us to get the overall PD, which is potential difference across them, because they are connected in series, the effective or the total or the overall effective potential difference is we add the PD here plus this one here plus this one here. Is that okay? So if you get the total PD here and get this PD here plus the one flowing across this one, you can find the unknown potential difference. Is that okay? Then the last thing we're going to look at is the total resistance. The total resistance, because they are connected in series, we have total resistance R is equals to what? R1 plus R2 plus R3. So I can also say that this is what? Total resistance, okay, that's R1 plus R2 plus R3. Is that okay? So one thing you must note is that for resistors in series, the same current flows across each of the resistors. But for you to get the effective potential difference, the effective potential difference will be what? The sum of the individual PD across the resistors. And also, the effective resistance is the sum of the resistance of each of the resistors. Alright, so let's look at resistors in parallel. Resistors in parallel. There are things we need to know when we consider resistors in parallel, okay? The current that entered into this will be separated. It will move here to this resistor R1, then move here to this resistor R2, move here to this resistor R3, okay? They ask to find the total current flowing. So how do we get the total current? The total current I is equals to the current flowing across R1, across R2, across R3. That is I is equals to I1 plus I2 plus I3. Is that okay? Alright, then the PD across them, because they are connected in parallel, the PD across them will be what? Will be the same. Will be the same. In my next video, I'm going to explain why the PD is the same. Okay, so it will be the same because all the positive terminals will come to a point here and all the negative terminals will come to a point here, so it will make them to look as if it is just one cell. All right, so the PD across them will be the same. That is V1 equals V2 equals V3 and is equal to the total what? PD. So the main thing you must note is that the current, total current, is the sum of the current flowing through each of the resistors. Then the PD is the same because they are connected in parallel. Okay, the total resistance across this and this is 1 over R total is equals to 1 over R1, 1 over R2 and 1 over R3. Then you must note that for two resistors only, okay, let me say for two resistors only, I will have a short method to solve it is equals to R1 times R2 all over R1 plus R2. That is only if you have just two resistors only. You can use this short method to solve for the effective resistance. Is that okay? Alright, so let us look at some examples of how we can apply current, Ohm's law and resistors together to see what we have. Stay tuned. Let's look at this example. Now we are given this diagram. We have P and what? Q. So we have this 1 ohm, 3 ohm, 1 ohm. Then this is an attachment, 2 ohm, 2 ohm and 2 ohm. They say we should calculate the effective resistance. How can we solve such problem? If you look at this diagram, anything that is in a loop or in a circle, they are connected in series because the same current flows. Okay, so when you look at this diagram now, you find out that this is connected in a loop, okay, but here we have an attachment. That means these three, 1 ohm, 3 ohm and 1 ohm, they are connected in series. But these ones, 2 ohm, 2 ohm and 2 ohm, they are also connected in series. Okay, but We are going to solve the three of them together because they are connected in series. Whatever thing we have will now be here, so that it will be in parallel with these three. Did you get me? I said that this is like a loop. So this is connected in series, okay? But there is an attachment from this end to this end, different from this. So for us to add this one together, we have to add these three because they are also connected in series separately, but was attached from these ends. So after adding the three of them, whatever thing we have, it will not be in parallel with these three. Okay? Alright, let's see how it goes. So you say the three resistors in series, that is this and this. Remember, for it to get series connection, we have R1 plus R2 plus R3. So that will give me 2 plus 2 plus 2. When we add that, it's going to give me what? 6 ohms, right? Now the diagram will change. I will have it this way. I'll have 1 ohm, 3 ohm, 1 ohm, right? Then this one I calculated will be here, which is what? 6 ohm, right? Now look at it now. This 6 ohm is in parallel with these three. So I will work them out again before I can now calculate the total effective resistance. Okay? So I will now say for resistors in parallel. So RT is equal to just these two. I will say R1 times R2 over what? R1 plus R2. Okay, that is 3 times 6. Okay, divided by what? 3 plus 6. Alright. 3 times 6 is 18, divided by 3 plus 6 is what? 9. Okay, so I will cancel 9 into itself 1, 9 into 18 2. So I have what? 2 ohms, right? So the diagram will change again to give me this, this, this. So this is 1 ohm, 2 ohm, because I've gotten these two to get 2 ohms here now. Then 1 ohm. Okay, so the final effective resistance becomes what? 1 plus 2 plus 1. So 1 plus 2 is 3, 3 plus 1 is 4. So I'm going to have 4 ohm resistors. That is the effective resistance. Okay, so you have seen that if you want to solve such a problem, you have to follow this step. This is a loop. This is an attachment from this end and this end. So if you're able to solve these three connected as a series connection, whatever thing you have, the diagram will change to be this way. Okay, so it will now be 3 ohm and 6 ohm will now be what? In parallel. You now use parallel connection, and I've told you already that for only two resistors only, are going to do what? Multiply by saying R1 times R2 over R1 plus R2. You have this. So we got it as what? We got it as what? 2 ohm, sorry. Okay, so that 2 ohm will now be here. That is what we have. It will be here. So we now add them together again to get the overall resistance. I hope you understand. So let's look at another example. Alright, let's look at this second example. Now we have 3 ohm, 3 ohm, 1 ohm, 3 ohm, 3 ohm. Okay, they are all connected across a 12 volt cell. So we have to find the total current flowing through the circuit. Okay, so for us to be able to do that, we are going to use the same method. These 3 ohm and 3 ohm, they are what? they are in series. Okay, so this and this also in series. So we have a connection here and connection here. Okay, this is where the current flows to separate to join them. So this becomes series, while this one is series. But if you calculate the effective resistance here and here, it will be in parallel with these two and these two, right? Okay, so I can decide to call this one R1, R2, R3, R4, and what? R5. Okay, so when we are done calculating the effective resistance, we can now get the current flowing through the circuit using Ohm's law. All right, okay, so we can say for total for total resistance R1, R2, R12, okay, is equals to R1 plus R2. That is 3 plus 3, which will give me what? 6 ohm. So R1 will give me 6 ohm. That is this plus this, right? Okay. I will now say R45 is equals to R4 plus R5. That is 3 plus 3 to give me 6 ohms, right? So now the diagram will change. We'll have it this way. We have, okay, okay. So this becomes 6 ohm, 6 ohm, and 1 ohm. How do we get the effective resistance? This becomes parallel because they are now connected in parallel. Okay, all right. We said for RT total for this, we are going to say what? R1 times R2 all over R1 plus R2, right? So we say 6 times 6 all over 6 plus 6. 6 times 6 is 36. 6 plus 6 is 12. By the time we divide it, 12 into itself 1, 12 into 36, we have what? We have 3. So R total here is equal to what? 3 ohms. Okay? Alright. So let's get the total current, the total resistance. Alright, the diagram will still change to be, we have this and this, okay, connected across 12 ohm PD. So this is 3 ohm, 1 ohm connected across 12 foot. So the final effective overall resistance here is what? RT is equals to R1 plus R2, that is 3 plus 1 is going to give me 4 ohms. Okay, now for us to get the overall current flowing through this circuit, we are going to use Ohm's law. V is equals to I what? R. So my PD here is 12 volts, alright, then is equals to I times 4. Therefore my current is equals to 12 over 4. 12 into is, sorry, 12 over 4. 4 into itself 1. 4 into 12, 3. So I'm going to have 3 what? Amperes. Wow. So this is how you can solve this problem, by working this one out to be in series and series. Diagram will change like this. Okay, so this will be in parallel with each other. You solve with parallel connection. Okay, the diagram will still change, and this is also being going to be in series. Then when we are done with that, we now use Ohm's law to find the total current flowing through the circuit. I hope this video was helpful. If you are joining us for the first time, please subscribe to this channel for more educative videos. Give it a thumbs up. If you have been watching this video and you have not subscribed, what are you waiting for? Subscribe for more educative videos. Okay, so I'm going to drop an assignment and you have to solve it and drop your answer in the comment section. See you next time in my next class. Bye.